Hello, I'm John Shavacco, the co-chair of the NY-GEO 2023 conference and a board member of the New York Geothermal Energy Organization. I'd like to welcome you to this recording of a live presentation from the conference, a two-day event which was held in Albany, New York on April 26th and 27th of 2023. This year's educational sessions and keynotes represent the latest in ground source heat pump system design, product innovations, and installation practices, along with important policy, regulatory, financing, and incentive updates. This presentation is one of over 40 sessions from the two-day event, all of which were recorded and available at NY-GEO's website, www.ny-geo.org, along with session descriptions and a link to download the slides from each of the sessions presented. NY-GEO is proud to make this content available to our members and other industry stakeholders, and if you are a member, thanks so much for your support and participation. If you find this content valuable and for some odd reason you are not yet a member, consider joining NY-GEO at the appropriate membership level with details available at our website. The live recording from the NY-GEO 2023 conference will start in just a moment. Thanks so much for listening.
Well, good morning. I'm Brock Yordy. Been in the industry my entire career. Grew up in a drilling family business and worked for some pretty big companies, Halliburton and Jeffco and Labe, and with that great team over at Midwest Geothermal. Was director of wells for Veolia in North America, and now I'm on to other stuff. I'm also a journalist with the Driller magazine, so gotten to have great conversations with Garen and many of you all in the industry and whatnot. And so today we're here to talk history of geothermal, and it's been a wild ride for ground source geothermal. And I think about where do you start with the history, and we got a lot of good history in this room. And a year ago, I interviewed Garen, and we got into a big discussion about, some of the basics, and I'll get back into that. But first, I want to introduce our panel and have them introduce themselves and get really into the meat and potatoes of this. Hi.
Hi.
You made it just in time.
I did.
You almost had me talking about how the indigenous people, found the caves with the heat springs, and that's how geothermal started, but we don't need to start there. All right, so I guess we'll start at the far end since the mic is closest to Tyler. Go ahead and introduce yourself, Tyler.
My name is Tyler Harbeck. I am lead product engineer for GeoPro Inc. I've been there for 15 years, and I currently sit on IXPO's board of directors.
Hi, my name is Adam Santry. I'm the owner of Allied Well Drilling and Allied Geothermal.
Cary Smith. I guess what I have to explain is I'm not a driller, but I've owned drilling rigs. I bet 22,000 feet was our target. And I came 25 years out of the oil and gas business as a drilling engineer. Then I moved into high temperature geo and low temperature geo. So we've been real active in promoting drillers, rights, if you will, and understand how they work and why they need to make money.
I'm Dave Rosick. Well, it's not loud. I'm Dave Rosick. I own Rosick Drilling. We're out of the Lake George area. I got into geothermal the last kind of recession we had. I took a short little course with Chuck Riemann, if anybody knew who he was. I was supposedly the geothermal guy back then, and got into it then, and it's been good for me. And I'm not strictly geothermal. Our main thing is water wells, but it's a good fit, and it's definitely good for, I think, for all of us.
Yeah, I'm Stan Reitsma. I'm CEO of GeoSource Energy, and we are now present in the U.S., but we're a Canadian company, founded in Canada. We have goals here, I guess, if you want to call it that, but majority of the work is in Canada, and we do a lot of urban multi-res buildings and hospitals and that kind of stuff. And so we've been at it for about 20 years. I was wondering why I was in here for the history of geothermal, but I guess I'm getting to that age as well, where maybe starting to see me as. Anyways, that's I'm not sure if that's a compliment, but anyways. Okay.
Well, I think from a history standpoint, you know, with Dr. Bose and Oklahoma State University, and the heat pumps, so we're in the 80s at that point, you know, late 70s, early 80s. And there was that focus, and then from that came IGSPA. And, you know, we're talking 35 plus years ago. You know, if we look at, we had shot hole drillers, and we had water well drillers, and we had oil and gas all coming in together trying to determine, you know, what are we doing? And our optics of hot rock versus, you know, ground source. And I think of the evolution of the history so far, our optics on the discussion of, so you're drilling for geo, you know, when you Google it, you know, and we think of what are our optics, you know, we still get that where it's energy production from an electricity standpoint. But, you know, 20 years, and you've been water well drilling for
50 years.
50. Adam, how old's your company?
We're 27 years old.
So it's, you know, we can see that arc. And Stan, you started in geothermal right from the get-go?
I was a university professor, and then I started drilling. So I did not come from a drilling family. I grew up on a farm. So yeah, we've come at this from different angles, I'm sure.
Jason, what got you, or not Jason, but Dave, what got you into geothermal?
What got us into it? Well, way back when we used to sub out from an open loop kind of a guy, and we just did the water well, and then he would tell us, well, we need an extra 5 gallons a minute, or go an extra 200 or 300 feet, and it'll work. Well, a lot of them didn't, because a lot of them didn't make much water. So that kind of fell by the wayside. And then like I said, the next recession of the housing market is when I got in. I don't remember the exact year, but we got into it just because it looked like I went to one of these conferences, and way back then they said, trade in your water well shoes and go geothermal. And after I left there, I was so hyped up, I was going to do it, and it's a good thing I didn't, because I probably wouldn't be here now, because it kind of fell by the wayside when oil went back down again. And but I think this is the time it's here to stay, not because of the price of oil, which is part of it, but because of the clean energy idea that the state wants and is going to do, and it's a good opportunity, I think, for all of us.
So a good question, if we look back, you know, from the inception of IGSPA and blast hole drillers or shot hole drillers and whatnot, how's your equipment evolved over the last 27 years, Adam?
That's probably one of the main. The equipment probably hasn't really evolved in the U.S. as much as it probably needs to be frank with you. It's kind of been, any of you who've been in this business, there's been a lot of starts and stops. And, you know, the manufacturing and investment in purely geothermal rigs is probably something that we're more seeing now, and that we really do lag behind on. You know, there have been a lot of advances, you know, as far as just with depth concerns. You know, everything, you know, as we're talking about the history of it, is everyone wants to just go deeper. You know, that's just the natural push. Deeper, 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 deeper. So for all you engineers out there, we get it. You want to go deeper. So that's been the main drive in the equipment. We are, I think, picking up a lot of technology from Europe and realizing that we can have smaller rigs and still go deeper. But I think that's a push and challenge that we're really behind, to be frank with you, here on.
Well, we have a resistance to change. And if I look at my father's drill company in 1987, what we spent for a drill rig versus, you know, walking the IGSPA show with the NGWA, a 40,000-pound rig was a minimum of $1 million. Cary, coming from, you know, being a drilling engineer and applying it into the shallow or the low heat. What have you seen?
You know, in the last couple of years, is the propensity is to go deeper. And we start to look at spaces. We talk about drilling the inner city. We have to come up with new and creative ways to do that. You know, right now, the limit everybody's talking about is 1,000 feet. We need to even look deeper. Some of the stuff at Cornell that I'm seeing is going where they're going to the deep and ultra deep to pick up the high temperature subsurface geothermal, true hot rocks. All these things need to start to meld together. We belong to a group called EGI, which is out of the University of Utah, and what we're doing is melding that. And I'd like to tell a real quick story if I could.
Please do.
You know, 25 years ago, I was working in the high temperature geothermal industry, and I had invented a mud system that would go to 650 degrees. That was necessary so that we could clean the hole and convert these holes to producing wells. And somebody told me, a guy from IXPA I met, told me, I know these guys that can heat and cool with hot water. I said, hot water? He said, oh yeah, geothermal, you know. And I said, oh, nuts. Anyway, needless to say, I went to the GEO conference, that is GEO, the hot rocks group, and stuff, talked to the man, heard him speak and everything else, and got interested in this. So we went into, from moving 22,000 feet deep and 22,000 feet deep, you know, kind of moving into the shallow work and started taking that oil and gas technology and moving it in towards what we could do with the drilling industry and trying to the way we can optimize it. You know, everything from bit selection to jet usage and things like that were not common. So I've seen a large innovation, but I agree with Adam. We're behind the times. You know, we don't really have a viable rig for drilling inside, for parking garages, for floors and foundations. A lot of stuff we need to innovate on, and it does exist. That technology is in Canada.
I think that's a unique perspective in being a fluids engineer with Halliburton for 10 years. I got voluntold that I was going to Ball State. I was going to be at Ball State for, you know, that first phase with an Indiana drilling company and then some folks out of Minnesota and whatnot coming together. And the discussion was, okay, these are 400-foot holes. How quickly can we drill them in a geology that has overburden into, you know, limestone and shale laminates, and how was that going to work? Kevin Austin was there, and there was plenty of discussions on, okay, can we do these 1,800 holes in an effective amount of time? And we talk about affordable rigs, or we talk about European rigs, or we talk about, you know, Scandinavian or whatnot. And for me, drilling, diesel and time are our most expensive aspects. And the deeper we go, the more rotation we want, the more complex we get. 500 feet, we really start changing how we manage that entire system. Tyler, from a depth standpoint and grouts and whatnot, there's been a big evolution in thermally enhanced grouts in the last 35 years.
100%. Initially, obviously, before my time, it was just a sack of bentonite and water. Eventually, sand was brought into the mix to increase thermal conductivity. What we found with sand, or what you may not know with sand, is it's very heavy. And so for the higher conductivities, you're looking at substances that weigh anywhere between 14 and 15 pounds per gallon. When graphite was introduced to the marketplace in 2013, it essentially allowed for a low-density alternative, but you now have the capability to achieve a much higher conductivity as well. And so something initially that may weigh 15 pounds per gallon, which would prove problematic below, say, 400 feet, the actual standing column pressure of the grout itself could overtake the bursting pressure of the pipe you're placing it around. Graphite essentially eliminates that problem. You know, now those same bursting pressures are seen at, say, 1,000 feet, and that doesn't account for the fact that the material doesn't stay fluid forever. So once it starts to set up, it becomes self-supporting, and so that 1,000 foot is assuming a 1,000-foot column of grout. But in real life application, you probably never actually see that full, 1,000-foot downforce.
And that goes right into grouting equipment. Any of the drilling companies want to talk about how we've evolved from there. You know, a 72% solids thermally enhanced grout with 400 pounds of sand was terrible thing to pump beyond 300-400 feet.
I think it's going I think it's kind of gone a little bit in conjunction too. Back to just some of the challenges that we face as we continue to evolve on design. We're not really seeing a lot of uniformity. So as we start going to larger loop sizes, it's just the equipment that you also need to place the loop. Okay, the different type of equipment, like a lot of the standard grouters out there, they were really, we're doing a lot of deeper hole work right now at our company, and a lot of the standard grouting equipment, it was insufficient to pump it. So we actually had to go to the concrete pumping industry and kind of develop our own. Same thing with loop placement. We had to have that built ourselves. So, as we continue, to change to go to these deeper holes, we also have to think, what size hole do you want to drill? Everyone talks about deeper, but then when we go to larger loops, you're actually increasing the borehole diameter as well. So, if we're really going to, I think where the industry is going, we're really going to scale this out. We bring this up all the time. We really do need some uniformity. So if there's gonna be major, investiture in equipment, developing drill rigs, loop placing equipment, grouting, it's not universal. The same rig that you might drill a 4 3/4 inch hole with, you might not drill a 6 inch hole to the same depth. You need different drill rods, which is different pullback. There's a lot of different factors that go in when we just change the size of the loop and the depth. That's something I think, if people want to see this really scale and come in at an affordable price and be able to mass produce this equipment, on the engineering side, I think we need to think as an industry, like, what are we trying to achieve, to get there? Because it all does go hand in hand. That drill rig with that grout pump, with just a different type of, some of the videos that we saw with the guys pushing that loop in by hand. You're not doing that with a 1,000-foot, 1.5-inch loop filled with water that's weighted to overcome your drill mud that you need a 8,000-pound Skytrack just to lift up. So, there's just a lot of, everything does go hand in hand in conjunction, I think, when we're designing equipment. It's every single piece of it.
And Courtney's going to, moderate that next piece on the evolution of where we need to go. And it's very important where we came from. And, Garen told me a story. I go, Garen, where did this 150 foot per ton come from? And what did you say?
Well, it's 200 feet per ton.
200 feet.
It's from a 1,500 square foot house, Stillwater, Oklahoma. And it's back when we used supplemental heat. And so they put in a heat pump with cooling load, which is 36,000 BTUs. And then the 55,000 BTUs to heat it, they use supplemental heat. That's where with 1.6 connectivity, that's where 200 feet per ton came from.
And this is pre-in situ thermal conductivity testing. And, so we've gathered the science, and we have the fundamentals. It's, Stan, you're drilling right now, and you're not using conventional mud rotary. What method are you?
Yeah, so I was going to talk a little bit. I want to touch base on what you were asking. What were the changes in geothermal drilling? And I mean, drilling itself, of course, is drilling. So we were talking about this last night a little bit. Changes do happen, but they're a bit slow. But I'm going to say some of the things that I've seen over the years was, downhole hammer, PDC bits. PDC bits probably weren't around 2005 or 6. They started showing up from oil and gas into geo. We brought them in. I can't remember exactly when we started. Some of the first ones, they were incredibly expensive and weren't very good, but they were better than trichome bits. And then we, eventually now the bits, bit technology has come both in cost and durability and performance has come a huge distance. So we're drilling in Brooklyn, New York with Brightcore and Lend-Lease, which you saw this morning. And that site, we had done some drilling in Corner Brook, Newfoundland. So I don't know if you know Canada at all, but it's way on the East Coast. They call it the West Coast, but it's the West Coast of Newfoundland. It's very confusing when they tell you I'm from the West Coast, and you're thinking Vancouver or Seattle, and they're actually still in the East Coast of Canada. But anyway, it's 24-hour drive, and then another 7-hour ferry ride, and another 2 hours from the ferry to the hospital where we were drilling for the new hospital. We had a lot of challenges with the bits, and hammer drilling was okay, but there was communication between boreholes, and the boreholes were, when they were communicating, they were burning out the loops next that were already installed. And we're still kind of confused as to exactly what was happening with those loops being destroyed. So we had to switch to water drilling or mud drilling, and that, of course, required either water hammer, which I know the Wasera guys are here, and Brightcore's here. We're looking at talking about that at some point probably, or PDC with water, some sort of a rotary bit, and that work there in terms of getting bits that actually could stand up and hold up to that geology are now being used in New York, and they're working. So we're drilling with water because there's such a high amount of water production there, and communication between boreholes is phenomenal. So if we start using air, you produce water, and it'll be running. We'll fill up the East River. There's just so much water there. But no, joking. But of course the communication between the boreholes and pushing grout out and all that stuff with air it makes it impossible. So some of that water drilling and so on. That's I'm going to say it's not new, but it's not widely applied in the geothermal space, and it's a little different. Talking about oil and gas, I mean, there's a lot of differences. There's probably more. There's some similarity with water wells too, but there's enough differences there again as well. That, for example, New York, the holes are 15 feet apart. There's 320 of them. There's fractures between them. They all talk to each other when you're drilling if you're not paying attention to that. That is not something you typically need to deal with in water well drilling. So there are some complexities that happen that are driving innovation. The other part, talking about rigs, I think one of the things we've been working very closely with a Canadian manufacturer in Quebec on building rigs that you don't need to be 6'4" and 24 years old or 28 years old to drill on, right? These machines are designed to be run by somebody who's used to playing Xbox, right? That's where we're going because that's who we got coming out, right? There's not very many big people, and I think Nigel's in the back there. He's running our New York group. Thanks, Nigel, of course, for coming. And we have our first woman driller starting in a week or so, and she's,
Yeah, absolutely.
But that's an evolution, right? And that's what we're looking for to get people in, is building machines that they can actually run, and not count on the guys from Nebraska to run it, right? So, that's
in Nebraska. Is that
I'm just saying they build them big out there. So, so there's that, and then of course also the evolution of the machine is to make it so that it's usable by people that don't need to have drilled for 20 years, a whole generation or multi-generations of drilling family to be able to drill a hole. You should be able to get in there and do a reasonably good job within 6 months of drilling or thereabouts with some training, and have machines that can actually deliver at a reasonable rate still without all that extra. So that's coming, and that's with the automation, rod handling, dual rotaries or sonics or those kind of things, so you can get to the rock without being a super finesse with mud drilling to get your casing in and gravel, that kind of stuff. We have, you have machines that just power through it and do it. So anyway, so there is a lot of innovation coming in.
I think that's a unique perspective on where our innovation's going, and getting to spend 5 years with Georgie Failing and their R&D group, east and west of the Mississippi and north and southeast, and we look at where we're drilling geothermal, and here we are in New York, and New York is a very diverse place. 14,000 years ago, some big chunks of ice just screwed everything up. And, perspectives of people buying drill rigs, from you to Dave and, Adam, your expectations of how that rig is tooled out. If we talk about consistency of how we're going to do boreholes, there's a reason we have many different drilling disciplines, and we look at the only cohesion that should be there is the least amount of impact possible, right? The least amount of solids created. How can we be surgical instead of being the industry that we are? Let's just get the next biggest hammer, and that's a piece of, I've seen us in the industry from looking at job sites that are just big, muddy sites to, well contained, not to mention our environmental aspect has gotten much more. You want to comment on that, Adam?
Hi, Brock, just ignore me. Good seeing you. Keep going.
Brock, I guess one comment on that. Stan mentioned PDC drilling and why it's not as maybe widely adopted. I know we do quite a bit of it, but it's usually a pretty select client because budget's still in many cases driving these decisions, and typically the price per foot and the cost per foot's higher, and it won't meet their budgetary concerns. Obviously, we have some clients who are willing to spend the extra, and with a lot of great programs out there, it's becoming more affordable. But that's one thing I think in most parts of the country, we're in 17 states, and we have 5 offices up and down the East Coast, and everyone wants to be like New York because you guys have done just such an amazing job up there. But a lot of times, their budgets don't allow. They want to go geothermal, but it really has to pencil out still, which is something that we still see. And then it's all about what's the most cost-effective way to install that system. So I know we do quite a bit of design build work where we're actually designing the loop fields, and that that's really geology is going. I know you have a great presentation later about how geology drives that. That really just drives design, but it also is going to drive methodology, what method we're going to use. So that's something that we're really seeing, because a lot of people, PDC drilling is a big buzzword a lot of times right now in our installation, because they don't. It's a lot of times less noisy as well. But sometimes that comes with an additional cost that you really have to make sure the client or the designer, I think, understands that up front.
So we had a question out in the audience. Yes.
So when you have communication between 2 wells, you immediately grout the well you just drilled, right? And will you still have communication once it's grouted? Do you have to wait like a day before you can drill an adjacent well?
Yeah, so the question is in relation to communication between boreholes and how you deal with that with grouting and so on. What we're seeing is if you're air drilling, especially if there's a lot of water production, so usually those things go together, communication, fractured rock and water production all, are in the same party. So if you're air drilling and you're, 400, 500 feet down, you hit your air and your hole's filled with water, it will try to find any way it can to get back out of the ground. And one is up the hole that you're drilling, but of course it'll also try to move sideways into other holes. And if you're using grouts, none of them, particularly the bentonite grouts, are just not resistant to that type of aggressive energy that's being put into it. So you'll start pushing grout out of holes. You'll push loops out of holes. It can get pretty crazy. So in order to overcome that, you get it. If you can drill with fluid or water or mud, because you don't have that aggressive start of the hole. When you turn your mud pump on, it's pretty timid compared to turning your air on with a hole full of water, which is aggressive.
It's unique because everything's about overcoming gravity for us. We're exerting pressure with a bit, bringing cuttings up out of the hole. How are we going to bring those cuttings up out of the hole? West of the Mississippi, in areas that, it's very deep to water, I can run air, and I'm running that air at 3,500 to 7,500 feet per minute uphole velocity. Mud is 60 feet to 150 feet. And then we go into dual tube or we go into different methods. It's limiting the impact. So if I'm going to be in a karst environment or something that's got communication, I need to understand how I'm going to minimize that impact. And then, yes, Mother Nature's fragile. So we have to, once we start communicating, we've broken that fracture gradient. I think of, I was really bad at wood shop because there was a really cute girl that I wanted to go to prom with. And so, I slammed this birdhouse together made out of pine so I could flirt with Amanda so she'd go to prom with me, right? I didn't pre-drill any of that. And once I split all that pine, all the paste and putty I could do, that birdhouse lasted about one Michigan summer before it fell apart. And it's the same thing to Mother Nature. Once we get in there and start blowing it apart, you know, we can Band-Aid it back together. The oil field spends lots of money doing that, but it's how do we minimize that impact? Yes?
Hold on.
Oh.
I was told that if we don't speak into the microphone, it does not get recorded. This is what happens when you put a driller in front of all this technical stuff.
So the part that I'm struggling with is the number of these wells that need to be done, and you're talking about having somebody with maybe 6 months of training, but you bring up the excellent point about not understanding the geology of the area. So one thing is interaction between the wells, but then also keeping it straight. So you have 15 foot between the two wells that are 1,000 feet, they're gonna stray. So how do you have somebody with only 6 months of training being able to do that?
Well, yeah, I mean, that's part of the that's part of the training. It's part of the equipment that you're using, and of course, deviation on boreholes is clearly a problem. But I'm not always convinced that more training always helps either. So getting the right people behind the sticks. We always joke that, you know, one day of doing the same thing over and over a day is still one day of experience. You know, we do see that within the drilling industry. Very common is this is how my dad did it and I do it and so on. We got to get away from that a little bit. So, you know, training, actual training that is, it's one thing we're working on very hard is putting together all the materials. How do we do everything that we do? Break down every job into distinct tasks, for example, and then put material together on how, what are those steps, right? And those pieces are all part of the training to get it to a point where you can actually train someone. So it's and drillers are notoriously bad for wanting to keep everything to themselves as well and going, it's a secret, right? And so we don't want to do that either, but you're nodding your head, I'm sure. Yeah. Anyway, I think that's a big part of the training. But you're right. I mean, there are situations where certain places, for example, that are going to be way worse than other ones, you may not put like we don't have any rookie drillers in New York for sure, because if we did, they would be having trouble. Now, we can speak to it a little bit there in terms of there is some huge difference in caliber of the people that we have, and they're all doing okay, and that's partly because of the oversight and those kind of things as well. So there's a number of factors to that.
Yeah, Dave.
One thing I'd like to comment on that is I've got guys that have been with us for a couple of years, and to put them themselves yet would be tough. If I had we have to do a job at Skidmore, I mean, I could have them there because it's pretty straightforward. You know, you do the first one's probably going to be like the 40th one. But we do a lot of residential, and it's like night and day difference from one job to the next. So you got to have somebody that knows how to run that drill rig when you get into problems. And I have some things on my phone, the one we just did for Aztec, thank you, Jeff, that we did one borehole, no room. We're next to Lake George. Can't get anything into the rivers and streams that go to the lake. The first one, two 500-footers, which, like I said, no room. We got as much silt fence over the septic systems and everything that we could. No room to bring roll-off containers in there to pump into. In the second borehole at 430 feet, we hit several hundred gallons a minute. It's flowing 100 gallons a minute over the top. And you talk about a couple of wet guys trying to contain that water. If it was some of the new guys, they'd be calling me up and say, "Well, we just left because we don't know what the heck to do." So there's some differences for big fields, and what a lot of us do are smaller residentials because everything is different.
Did you want to comment? You know, and real quick, I'm just going to say, as we get to a drilling engineer, we forget really good fundamentals along the way, and we're making same mistakes we made 35 years ago. PDCs create smaller cuttings, are going to run havoc on a mud system. Proper bottom hole assembly, which Cary's about to jump into, I hope, is exactly, we can drill straight holes. It's just about managing time and speed and not hitting boards. And I saw it with Midwest, and LA, and I saw it with Ortman and Triton and Ball State. It's just proper fundamentals.
You know, that ties into the comment I really did want to make about training. You know, when I started in the geothermal was 25 years ago, and with this revelation that I could cool with hot water, and as we went through that, but we were coming out of an era where there was a giant oil field explosion and it crashed, and that was the late 80s, or mid 80s to late 80s, early 90s. But we had trained people, and we had a lot of trained people looking for jobs. We had over, just about 5,000 rigs. Now we're talking about large-scale rigs, and that rig count went down to 426, and that was the lowest it got in the whole year. So we had all these people that we had trained. Those people are now my age, and they're looking at it. They're not out on the drilling rig. What we don't have is that training we need. And we've been talking to the unions, we've been talking to all kinds of different people, but we need to start, and as long as this industry is starting to take off, we need to be the seed of that. And, that's going to help both the shot holing industry and the geothermal industry. And no, I'm not going to get into bottom hole assemblies. But, straight hole drilling and technology has to be transmitted. And we need to recruit the people to transmit that. We need to start our schools again. We need to start at directional, look at directional drilling. The guys that are drilling the flat rods, that's a whole nother technology as we go. The horizontal drillers and so forth, and the angle drillers, and that's completely different. I can remember cutting my first angle in the oil field, 1 mile at about 8,000 feet. It was really tough. But we've got to start to look at the people, what we can do to get the people, because the bottleneck in this industry is going to be the drilling, and it's going to be the drillers. If we don't get people trained and get people out there right now to help Stan and Adam and crew, and Dave, we're going to lose it. We're going to lose this industry. So this really talking about the most and key piece of what we're doing. And then if we can apply the technology, deeper, cheaper works. I can remember putting PDC bits together back in the 80s. We worked for Diamond Board and stuff, and we were doing the Uinta Basin. The last 5,000 feet was all diamond drilling, which is PDC, diamonds, and so forth. We helped Hughes develop their stuff and stuff. It works, but it takes special technology. Along with it, we have to use special polymers and so forth that can increase lubricity and stuff. So as we do that, it changes the whole dynamics of the equipment we have out there and stuff. And we as engineers and designers have to recognize what these gentlemen have to go through and what they have to build to turn around and get their job done. And if we want to turn around and I guess, make New York 50% carbon free, so we're going to need to get out there, because I'll tell you what, Colorado's right behind you, Massachusetts is right behind you, Connecticut's picking up, Maryland is starting to pick up, and we're starting to see a lot of activity in other states that are saying and recognize that our technology is good.
And I guess one other point, just the training. I know a big thing for us has been, just who are we out recruiting? So we're a 100% bilingual company. Over 95% of our employees are minorities. So every piece of literature that we do is in both English and Spanish. We have a monthly training meeting, a monthly safety meeting. Just the nature of our staff, that's now 100% in Spanish. And, we don't make any new hires, anyone in management, you're required to be bilingual. Just making sure that we are, very inclusive, I think, in where we're looking for future employees. And that's been a really big driver for us, and it's been great. We've had really great success growing our company and growing. People always say, you can't find drillers. We don't have an issue with that. And I think it's just because, the inclusivity, I think, is just very, very important as we grow our industry, and that we kind of change the demographics a little bit. I think in the future of who's at drilling conventions and who's at these NY-GEO meetings, I think that's going to be a really important thing as we try to push this industry forward to get to a lot of these goals. And I know that's really helped us.
Just to throw out there, we have the next session right after this is focused on training and workforce development. So let's move on to questions as we go through here.
Just a couple of seconds. My name is Gino from Ground Heat.
And we've done some work in Eastern Europe and Western Europe. There was a comment about Europe, depth, and grout. So Europe, quite a bit of Europe, some of them don't use grout. They use water as a backup, so they can go deeper. Also, you have Europe probably has sometimes double U-tubes instead of single U-tubes. Something's common there, which is not common in North America. And the other thing, too, is we were doing some work in northern Italy. We did the 3 IKEAs, and across the street in Switzerland, they were drilling 1,200-foot holes, 1,300-foot holes. So I went over there and chatted for a week with some of the drillers. And there is a limit which you can do with the depth. So at the 1,200, 1,300-foot depths, there was a negative production. For example, as you go deeper and the two pipes are together, you're not going to get the capacity anymore. You may end up losing capacity as at the top 200 feet or 300 feet. So there would be a limit unless you split the pipes around. You have a concentric piping or some other thing. You will have a problem with the. So there's a limit. There will be a limit on production, if nothing else.
Hi, I'm Erica Herman. I work with the Southern Tier Hub in Schuyler and Steuben down south from here. And I had a question for Adam to do with your employee ratio. I was wondering what job training you've been using. Like, are you using any like ponds or other funding for the employees you have? I was also wondering how you also maintain retention as well.
Sure. No, we have an apprenticeship program at our company. We actually created about 12, 13 years ago. We have our own apprenticeship program that we put together. We kind of based it off a similar model down where we're from, and we internally developed that because there wasn't really anything out there. But no, we haven't, no outside sources of funding or anything like that. Through our apprenticeship program and, I think just growth of the company, we've had our average employee's been with us almost 9 years, and we have a little under 200 employees now. So I think giving them that upward mobility at the company has been really key. And, that apprenticeship program kind of gives them those steps of where they're going to go next. We also participate in quite a bit of like local workforce hiring, which has actually been, I know some people shy away from that, but it was actually very beneficial to us. And we've had a lot of those employees that we've met through local workforce hiring actually stay on with our firm. They worked on an 8-month project with us, and it was a great fit. And they end up, they just stayed with the company, and they've been with us for years after. But I just think, having a very clear laid out program at your company, showing the next steps, because, I think someone said it earlier, typically I know a lot of firms, they don't want to share that knowledge. Well, I think you have to really give them a pathway for if you train your next driller, then you're moving up at that company to a superintendent's role, then to a senior superintendent role. And then eventually, most drillers want to get out of the field. They want to come into the office eventually because it is, like a lot of people say, it's a bit of a younger man's game sometimes. So we've had a lot of guys who have actually progressed all the way. We don't hire really outside drillers. So if you want to drill for us, you're going to start at the bottom and work your way up. And they see that, and that they pass that along, knowing that if I train my future replacement, that gives me the chance to have that upward mobility. And that's been something that's been just, a real key for us for employee retention. But then also it's just, I think it's good culture. So hope that answered that.
We have about 8 minutes left before we move over to the next session. Sarah?
Hi, Sarah Collada with Siemens. This is my first New York GEO conference, and I'm going to ask a really naive question at risk of looking silly. But no one's talking about horizontal drilling much. I'm hearing a lot about vertical, and I live in a residential neighborhood where we're looking at building a district geothermal system for 30 homes in a community building. And the mechanical contractor that we've used for air source heat pumps is suggesting a very long, shallow horizontal loop. And I wondered where that fits in the history of drilling, and if anyone would comment on that.
There we go. The horizontals that we've done, and I've done a few when we used to do the whole system start to finish. But traditionally, it's not drilling; it's done with a backhoe or something. And the reason that the verticals have taken over for the most part, because most people don't have the room to go from this property to the next property, and to put all that loop in the ground. And then if you do have the yard for it, you got to remember that it's there. Like, if you want to put a pool in your backyard in 10 years, you're going to find your loop field pretty quickly, because most of the time the horizontals are 5 to 7 feet deep. So it really restricts what you have for room and what you have for capability of the heat pump.
I've got a little different take on that. And you're talking about horizontal drilling. He's talking about horizontal installations and slinky loops and this kind of thing. When we were starting in this industry, we started looking at horizontal drilling because one reason we were at a high school in rural Utah that the only place we had to drill was the football field. And if we messed up the football field, we screwed up the whole school. So we had to horizontally drill across the side of the football field. We went in one track and came up about 250 feet on the track on the other side. That kind of stuff. But at that time we had to wait about 6 months to get a horizontal rig because they were very uncommon. And they're just starting to be. And today, they're more and more common. You see one on every street corner with people drilling fiber optics and everything else and stuff. These people all can be converted to geothermal and stuff. And you're talking about doing that. That is a legitimate way. And sometimes we go 30 or 40 feet under and then straight. Okay? So, it's a different thing. It's a different type of technology. Every one of these technologies is applicable to what we do and stuff. They're just different ways to handle the problem.
12 years ago with Ditch Witch and Vermeer, both were getting into horizontal, and they're horizontal rig manufacturers. And we saw several companies pop up that were doing horizontal that was either an angled bore that didn't come back out, or we had full horizontal bores. And Tyler's here, so I'm going to throw him on the spot. But, one of our complexities is vertical, everything is falling due to gravity, and horizontal, I have this much space where the cutting. So when we go to grout that loop in, and grout being very important to us from an environmental standpoint and from a conductivity standpoint, it was difficult to get pumpable grouts that we could pull and bring back. And that was something now with graphite and whatnot. Tyler, have you seen anything on horizontal grouts that improvements?
Yes, more to the graphite side of things. So initially, if you were going to thermally enhance that horizontal bore, you essentially had to drill your hole and then pull a trimming line back towards you when you would pull your drill stem, and then pull that trimming line back to the other side where you essentially came out of the ground. And time consuming, it's very difficult. A lot of times your hole would cave in and you'd either lose your drill stem or, things of that nature. Sand's very, very abrasive. And so you couldn't run it down your drill stem. In addition, the annulus through those drill stems doing that horizontal work was only 1 inch. So not only would you plug it, it would also wreck your tooling on the end of that drill stem. Graphite essentially eliminated that problem. One, graphite by itself is a lubricant, and two, it's much thinner. And so what it allowed a lot of horizontal drillers to do was, instead of having to pull trimmy back and then trimmy back out the other side, they could actually pump the graphite right down their drill stem with the mud pump that was on the unit itself. It eliminated that step. Personally, we see a lot of horizontal in the Midwest. I know a lot of it's going to come down to space is obviously your main concern, but then too, a lot of it comes down to where do they hit rock. If you've got enough space where you can actually go below 10, 15 feet, that's fine. I know New York is, it's kind of like a box of chocolates depending on the area you're at. So that's going to be your limiting factors with a horizontal system.
Yeah, Brock, just not really a question, just a comment on horizontal boring. We've been I'm Michael Albertson with Water Furnace. I don't install loops anymore. That's kind of a past life. But as far as horizontal boring, we were installing horizontal boring back in '83, '84, and I will tell you there are ample horizontal boring units from Vermeer Ditch Witch out there. They're deployed in multiple states. Sometimes we end up having to really educate. If you're going to get a horizontal boring contractor in, you're educating them as far as how to price the job correctly, because a lot of the horizontal boring contractors are making one shot a day, and they're charging 100, 120 bucks a foot, and that doesn't work for us. So if you educate them, and we have a list of horizontal boring contractors in every single 50 states, you know, and even globally, that can perform this work. But one cool thing about horizontal boring is obviously you can directionally drill and you can control where that's going and pull your loops back in or do what's called a vertical. But the other thing is you can stack those loops, say underneath the parking lot, ball field, building, whatever the heck it is, and then you can stack them and fan them out. So I can have tons of contacts on horizontal boring operators, so if anybody needs those, please let me know and we'll get them to you.
I guess we do have time for one more if somebody wants to throw a quick one out. Hold on.
Run. You only have 2 minutes.
If you could, just a quick history of the install cost over, I don't know, last 15, 20 years.
This is part of the problem. The driller's always the rough guy. He's the guy that's not in the room because he's gone first. But the truth is our drilling costs and everything are about the same as they were 20 years ago, plus or minus 20%. And it's getting better in some places, but it's not getting to the point where we really are, I think, taking advantage of the situation. I think most of the time the driller gets a bum rap.
You know, I would say due to environmental, constraints, fuel, everything, Tier 4 final, I think there's plenty that have impacted drilling costs. And all of these men up here and several of the great female-owned drilling companies that are out west and whatnot, again, if we look at the beginning of IGSPA to today and a $200,000 drill rig to $1,040,000 drill rig, I mean, Adam could have an island for the amount of rigs he's got right now, or the same with Stan. It's from a financial feasibility standpoint, it's a high-risk business. Go ahead.
Costs are much higher than that. I mean, from equipment costs, I mean, a standard crew to tool it out to go out and drill, it's over probably 1.5. Labor costs have really risen, which is a great thing, and for our guys. But my labor costs have doubled. Insurance costs are through the roof. That's another big driver. Materials are higher. Design is driving it a lot on the way that some of these jobs are being designed. Obviously, the deeper we go, there is a cost premium with that. And then a lot of these designs then, as we're going to deeper boreholes, we haven't even really gotten into this at all today, but that then drives a much higher horizontal cost because we're dealing with much larger piping, right? And obviously the much larger cooling times you're getting in. We're the biggest utility contractor on any job we are anymore, which leads to greater flushing times. I mean, the whole entire horizontal portion of the project is now through the roof when you're drilling 900-foot, 1.5-inch wells and tying it into 8-inch mains. When I first started, I mean, a 2-inch horizontal run was big. Now we're seeing standard 6- and 8-inch headers on a lot of jobs. So I think the cost profile, where we're probably delivering a lot more BTUs, the cost per project is it's certainly up, and we're seeing that kind of, I think, across the board. And I know in our area, pretty much all construction facets, but it's, I think, just general construction costs are a lot higher, but then I think design is driving that some too.
I think we'll end it there. We'll get ready for the next session. Part of what we're doing with these, obviously, we've got probably over 100 people in this room, and everybody has a perspective, everybody has information, everybody has knowledge. We're here for quite a while today. So as you get questions, make sure that you grab one of these panelists, grab somebody in the room and have the questions. Have the conversations. This is a key piece of what we're doing in New York State. Ultimately, the utilities need our technology. We're the only thing that can provide centuries worth of energy for very little cost. Yeah, it costs a little bit up front, but long term, it's the only solution we have. So let's get off the cost reduction. That's always been a big thing over the years. I don't think we're heading that way. So thank you, everybody. Thank you, Brock. We'll get the next panel up here.